Good morning, everyone. My name is Kalyan Kumar Reddy. Today, our topic is basic definition of sinusoidal response of the system. Basic definition of sinusoidal response of the system. To sinusoidal response. The sinusoidal response refers to how a system reacts to sinusoidal inputs. This response is circular in the study of linear time LTI system. Understanding this concept helps it in analyzation to behavior of variation physical systems. Here you see sinusoidal response of DS motor. Input signal here blue lines and motor speed is orange and red lines. Speed and time. Definition of sinusoidal input. A sinusoidal input is a function that varies with time in sine or cosine waveform. Mathematically, it can be expressed as a sine omega t plus, where a is amplitude, is angular frequency, and is phase angle. Sinusoidal inputs are fundamental in signal processing and control system. Here you see sinusoidal input formula is amplitude, the period 2 by b, phase horizontal shift is c, vertical shift is d. The same applies for the cosine function. System response characteristics. The response of a system to a sinusoidal input is also sinusoidal, maintaining the same frequency. The characteristics of the some response include amplitude, scaling, and the phase shift. These characteristics are determined by the system's transfer function or frequency response. Amplitude and the phase shift. The amplitude of the output sinusoidal response may differ from input's amplitude due to the system dynamics. Phase shift indicates the time delay between input and output waveforms. Both amplitudes and phase shift are curricular for understanding system stability and perform. Frequency response function. The frequency response function characteristics how to a system responds to different frequencies of the input signals. It is often represented as H ohm, where J is the imaginary unit and ohm is angular frequency. Analyzing the frequency response helps in designing filters and pre-detecting system behavior. Board plot representation. Board plots are graphically representations of the frequency response of a system. They depicted gain and phase shift as a function of frequency on a logarithmic scale. Bond plots Bond ports are invaluable tools for engineers to assess system stabilities and performance. Steady state and transit response. The sinusoidal response can be divided into steady state and transit components. The steady state response is the behavior of the system after transits have decayed. Transition response occurs during the initial adjustment phase when the input is first applied. Practical application sinusoidal response analyzing is widely used to electrical engineering, such as circuits and control system. It is essential for designing system that requires crucial frequency control like oscillators. This analyzation also plays a significant role in telecommunication and signal processing. Here, finally, we conclude this topic. Understanding the sinusoidal response of system is fundamental in engineering and physical. It provides insights into system behavior under inputs and helps in effective system design. Mastery of the concept enables engineering to create stable and effective system across various applications. Thank you.